So this problem says compute the Taylor series of the given function around x equals 1. So again, we need our formula. So here's our formula. So I'm going to need a bunch of derivatives until I understand what my nth derivative is. So that's what I'm going to do first. So a bunch of derivatives. So f prime of x, that's going to be negative 1 over x squared. Okay. F double prime of x, that's going to be negative 1 times negative 2 over x cubed. Now notice what I'm doing here. I'm not multiplying it out. So again, it's better that we don't multiply it out so we can actually see the pattern of what's going on here. So f triple prime of x, that's a terrible looking x I drew. Let me redo it. Okay, that's going to be negative 1 times negative 2 times negative 3 over x to the 4th. Okay, so now I'm going to do one more, and hopefully you guys see it by then. Okay, so that's negative 1 times negative 2 times negative 3 times negative 4 over x to the 5th. All right, and then when I go dot, 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 dot down, my fn of x is going to be, think about those negatives. So when I'm even, I'm going to have an even number of negatives on my derivative. And when I have odd derivatives, those are going to be odd, so they're going to be negatives. So I'm going to have a negative 1 to the, would an n work? Because when it's even, it's even. Yeah, that would work. Okay, and then I'm going to have a 1 times 2 times 3 times 4 on a fourth derivative. 1 times 2 times 3 on a third derivative. So that pattern is going to be n factorial. And then on the bottom, that's going to be x to the n. Minus, or plus 1. There it is. So now, all we're looking at here are the top pieces of each of these. All the derivatives, that's it. So we need to find fn of a. So now that's what we're going to do. So now then for the first one, f of a, which is 1 here because we're around a. So that's going to be 1 over 1, which is 1. Okay. F prime of 1. Okay, that's going to equal negative 1. And f double prime of 1. That's going to equal negative 1 times negative 2. F triple prime of 1. That's going to be negative 1 times negative 2 times negative 3. F fourth derivative of 1. That's going to be negative 1 times negative 2 times negative 3 times negative 4. And when I go all the way down to fn of 1, that's just going to be hang on. Negative 1 to the n times n factorial. Because think about it, I'm going to put a 1 down here, and that's just going to be 1 on the bottom. So it's going to be this here. So that's going to be my f of a. So now we found all of those, and we found our fn of 1, and that's going to be negative 1 to the n factorial. So now all we're going to do is use our fancy formula here. So we're looking for this guy right here. All right, so now if you think about it, we found that first piece now. So if I plug everything in, I can see how that all comes into play. So here we go. We're going to get a 1 for f of a plus a negative 1, so I'll put a minus there, a minus 1 x. Now keep in mind here, we're centered about, we're centered about 1, so it's going to be x minus 1. Okay, then the next one, let me write it a little smaller here because I'm going to have to put a lot in here. Okay, x minus 1. The next one's going to be a plus, right? Plus, and then that's going to be 1 times 2. So I'm just going to put in here negative 1 times negative 2. Negative 1 times negative 2 over 2 factorial x minus 1 squared. There's the second one. And then the formula says minus, okay, I don't know if I should alternate signs or not yet. I think that's okay. So that's what I was contemplating on. So that's going to be negative 1. Actually, if I'm going to put the negatives in there, I might have to make these all plus. Yeah, I'll do that. That'll make it a little easier to see what's going on too. So negative 1 times negative 2 times negative 3 over 3 factorial x minus 1 cubed. And then I go plus dot dot dot. So then the one here is going to be our one we have at the bottom here. So that's going to be our negative 1, or plus, negative 1 to the n, and n factorial on top over n factorial by the formula x minus 1 to the n. Okay, hopefully that's okay for everyone. Now notice this, those n factorials cancel out. So my nth term actually turns out to be, now I'm going to do it in red because I want you to kind of see this. That's going to be negative 1 to the n to the x minus 1 to the n. Hang on a minute. We're good. So there it is. So now I can turn this into the series. That's what's nice about this. Once I have that nth term, I have the series for this. And that's what the Taylor series would be. So there's our answer. Done. So here's another problem. It says evaluate the limit using Taylor series about x equals 0. Okay, so here's our limit here. Now what we're going to do is we're going to use a Taylor series here. So instead of cosine of x, we're going to put the Taylor series in its place. So now what that means I'd have to do if I don't know the Taylor series of cosine of x is I would have to start with the f of x. And that's cosine of x. And then I'd have to start going through a ton of derivatives. And then that's going to be negative sine of x. Okay, so I'm just going to go through this process really fast. Oops, I'm going to stop this video here and I'm going to start this one on a new video. Sorry for the mix-up on this.